All right, I'm working on, yeah, my last video was ridiculous because my microphone, or the mic plug was not plugged into the camera. Ridiculous. I'm still working on the audio. I'll get it mastered here at some point, but I need to get to work on showing you some homework problems. So I'm on 11.2, doing number 5 through 13 odd. So let's take a look at number 5. We have limit as the ordered pair xy approaches the origin 0, 0 of x to the 4th minus 4y squared over x squared plus 2y squared. All right, so what I want to do is figure out what's happening as x and y both approach 0. So it's obvious that if I let x and y be 0 in here, I get 0 over 0, which is undefined. So we've got to try and figure out if the limit exists, and then if it does, we need to find out what it is, and if it doesn't, we need to say that it does not exist. So for this one, let's try first approaching along going along the identity. Let's go along the line y equals x and see what happens. So what I'm going to do is I'm going to now take the limit as x approaches 0, 0 because I'm letting y be equal to x. And so this becomes x to the 4th minus 4x squared over x squared plus 2x squared. So replacing the y's with x's. And then what you get is the limit as xx approaches 0, 0 of negative 3x squared over, on the bottom, 3x squared. And the x squareds cancel, you just get negative 3 over 3, this equals 1. So it looks like as we approach along y equals x, we get 1. Now does that mean that the limit exists and that the limit is 1? Well, no, we have to approach along some other path to see if perhaps we get a different limit. So we could approach along, let's go along the x-axis. So let's go along here. We're approaching the origin. So first thing we did was we approached the origin from here, and we saw that our function's value was approaching 1. Let's approach now along the line, this horizontal line, which has got the equation y is equal to 0. So if I come back in here and I redo this limit, but I approach along y is 0, then I replace my y's with 0, it's going to be this. And on the bottom, it'll be 0 also. And we just get x to the 4th over x squared. So I just replace my y's with 0s. And I get this, which is x squared. I'm approaching along y equals 0. And that's just equal to 0. So as we approach in here, our function approaches 0. Which is different than approaching from this way. So we would say that the limit does not exist. So this limit does not exist since it's two different values from two different paths. All right, so how about number 7? We're approaching the origin y squared sine squared x. X to the 4th, I think it was plus y to the 4th, I'll check. It's number 7. Yeah. Yep, okay, so let's try again. Let's go along that, I like that x-axis. What I see here is if I do that, if I let that, I should get just 0. Let's see. Along here, y equals 0, then we're doing the limit as x0 approaches 0, 0. And then plugging in for y0, we get 0 over x to the 4th. And then as x goes to 0, oh actually, since y is 0, right, it is identically 0. It's not getting close to 0, y is 0. This right here is just going to be 0, and so we get 0. So approaching along here, along the x-axis, we get a limit of 0. So let's now try a different path. Let's try the y-axis. Come in this way. And what we get, this is x is 0. So if I replace x's with zeros here, I get limit 0y approaches 0, 0. So I'm replacing my x with 0. Sine of 0, 0. So the top again is 0. The bottom is y to the 4th, but that's 0 again. So that didn't tell me anything. Well, it told me that coming in from this way, I'm also approaching 0. But that's not enough. I've got to be able to convince myself that from every path, it's approaching 0 now. So let me try a different path, and maybe I can get this thing to screw up. Y equals x would probably be the next one. Let's try that, the diagonal. This y is x. So this limit now becomes the limit as x approaches 0, 0. So I replace all my y's with x's. And what I can do is rewrite limit. I'm gonna basically cancel out a factor of x squared here. Just a second, you'll see this. So I have on the top x squared sine squared x. On the bottom, this is 2x to the 4th. And so what I can do is cancel this, and this will become x squared. And then as x approaches 0, you get 0 over 0. But you might recall from Cal 1 that once you're here at this point, you could use L'Hopital's rule, or you could recognize one of those important limits, Cal 1, that we teach right in the beginning. If I take sine x squared and I rewrite it as sine x times sine x, then I take x squared and I write it as x over x times x on the bottom, then I have a 2 here, so times 1/2. This is the same expression, and I know from Cal 1 that this limit goes to 1, and this limit goes to 1 also, and then times 1/2. So this limit should be equal to 1/2. And so what we see is when we are approaching the origin through the diagonal, we get 1/2 instead of 0. So that we got 2 different limits from 2 different paths, therefore this limit does not exist. All right, so let's look at number 9. Limit, we're going to the origin, xy over square root of x squared plus y squared. X squared over square root of x squared plus y squared. The limit as xy approaches 0, 0. So let's first go along, y equals 0, okay, which is a vertical line. If we do that, it's the limit as x0 approaches 0, 0. What happens if we replace the y's with 0? We get 0 on top. On the bottom, we get square root of x squared. This limit is 0. Let's try it along x equals 0. We get limit as 0y approaches 0, 0. Replace x with 0, we get 0 over square root y squared. That again is 0. Let's try the diagonal, y equals x. Limit as xx approaches 0, 0. So replace all your y's with x's. X squared over square root of x squared plus x squared is 2x squared, which is equal to, let's see, on the top we get, well, what can we do? We get x, sorry, I'm just rewriting this. This is x squared over root 2 times root x squared. And that's going to be equal to x squared over root 2 times the absolute value of x. And, well, what does this tell us? Essentially, if x is a positive number, which it won't always be, but if x is a positive number, right? Let's say x is positive. If x is greater than 0, then the absolute value of x is equal to x. So what you have is x squared over x times root 2. And then one of the x's cancels, and you just get x over root 2. And if you let x go to 0 now, you get 0. Now, if x is negative, right, then the absolute value of x is going to be a negative number. I'm sorry, write it this way. Right, so x squared is on top. So if x is a negative number, the absolute value of x is still going to be positive. So what we'll do is we'll cancel one of these out, right? But because the top one is negative and the bottom one is positive, this would give you a -1. But it doesn't matter because you would basically have a -1 sitting in front here, and you get 0 over this root, which goes away to 0 still. So either way, you're going to get 0. So it looks like all of these are telling me 0. So maybe it is 0. And the only way we can actually tell is to use something like a squeeze theorem to squeeze it between two things. So what I need to do is see if I can't get this thing stuck between two things that I know both go to 0. So this is definitely, well, we won't even do that yet. Let's try and see if we can't get a nice squeeze on this. How about trying to look at the absolute value of this? Okay, just for the sake of not having to worry about negatives right now. That's definitely greater than or equal to 0. So what can I say is bigger than this? Well, if you just look at this piece right here, okay, just look at y over the square root of x squared plus y squared. Just this piece right here. If x is 0, right, if x is 0, then that's just right there, y over square root of y squared, right, which would be the same as basically y over the absolute value of y, which is either going to be -1 or +1, depending on what y is. So if I take now, what I'm trying to get at is this right here, let's look at its absolute value. The absolute value of that is definitely going to be smaller than y over, since I did the absolute value of the whole thing, it doesn't matter, y over the square root of y squared. See if that makes sense. I'm trying to back up here. This piece right here, if I look at its absolute value, since x squared is being added to y squared, this is bigger than just y squared by itself. If that's bigger on the bottom, this fraction is smaller than this one. But this is just equal to 1, right? So what I'm getting at is that this right here, right? This right here is less than 1. This number right here, whatever it turns out to be, is always less than 1. So x times something less than 1 must be smaller than just the absolute value of x. Yeah, times 1. So the absolute value of x times something smaller than 1, which we're saying right here, must be less than or equal to absolute value of x times 1. And if we have that, then what we can do at this point is we can take the limit as xy approaches 0, 0 on all three of these. So where's this one going to go? Well, nothing. Nothing happens to it because it's already 0. And on this side, what happens if I let x go to 0 here? I get 0. And so this has to be squeezed between those two. And through the squeeze theorem, pretty much if the absolute value of this function is going to be squeezed between 0 and 0, then it doesn't matter if it's negative either, because if it's squeezed between 0, 0 is neither positive nor negative, so it's going to get squeezed in between, and the only number it can go to then, whether or not it's positive or negative, the only number it can go to is going to be 0. So this limit is 0. I don't know if I did a very good job of explaining that. I apologize. If you have questions, you can let me know. What's next? What did I say to go to? 11? Let's try 11 now. X squared y e to the y. X squared y e to the y over x to the 4th plus 4y squared. All right, let's try a couple of things. Now I'm going to shorten this up because of time. I've got a meeting here in a little bit. Let's go along, first of all, x equals 0. If x equals 0, I'm going to do a limit. I'm just going to write L instead of this whole thing, okay? I'm going to do the limit. I'll let x go to 0 here. I get 0 on top. I get 0 on top. On the bottom, I get 4y squared. So that's 0. If I let y equal 0, I get the limit, all this stuff. Y0 kills off the top. I get 0 over x to the 4th. That's 0. Okay, so far so good. Let's let y equals x. So I do that limit. Now I'm going to go, x goes to 0, 0. All my y's are going to be replaced with x's. So x cubed e to the x over, this is going to become x to the 4th plus 4x squared. I can factor out an x squared and cancel, so I'll get x e to the x over, let's see, I factored it out, an x squared, right? So I get x squared plus 4, like that. And then the question is, let me write it down. I did x squared times x e to the x over, I pulled out an x squared like that, and I canceled an x squared. So that's what I did there. I'm still doing a limit here. As x goes to 0, right? As x goes to 0, which is where we're headed, we get 0 over what? 0 over 4, which is 0. So it looks like we're getting 0 the whole time, and it looks like maybe squeeze theorem might be where we go. But let's try this. Let's try y is x squared. So what I'm doing is I'm actually approaching the origin along this parabola. So I'm coming in like this. And so I'm going to do the limit. This one, I'm going to write it out. Limit x squared approaches 0, 0. So I'm replacing all my y's with x squareds. So x squared, y is x squared, e to the x squared over x to the 4th plus 4 times y squared. But remember, y is x, so x squared squared, that's x to the 4th. And notice that on the top, this is x to the 4th. This is 5x to the 4th, and the x to the 4ths cancel. And so that becomes equal to the limit, all that stuff again, of e to the x squared over, remember the x to the 4ths canceled, so over 5. And as x goes to 0, e to the 0 is 1, so you get 1/5. And that's not 0, right? That's what we've been getting. So the limit does not exist. And that was number 11, sorry. That was number 11. Okay, 13. 13. What did I assign up through? So I don't know if I have time for this. 13, yeah, I did assign through 13. 13's pretty tricky. I'm going to give you a hint on 13, and I'll let you do it yourself. You're going to do limit as xy approaches 0, 0 of x squared plus y squared over square root x squared plus y squared plus 1 minus 1. And you can try all these different things, like x is 0, y is 0. Let's just try x is 0 real quick. X, if we're coming in along x is 0, what happens? We get y squared over square root y squared plus 1 minus 1. And so what you're going to get is 0 over 0. So that's going to not be nice. And then if we do y is 0, we get the same thing but in x's, and it's still not nice. So we're not getting anything real clean. So the hint to you here is to do something very unnatural. I want you to take this and multiply it by its conjugate of the bottom there. So this minus 1 instead, multiplied by this plus 1 on top and bottom. And see what happens. If you do that, this algebraically will simplify and the limit becomes very easy to do, and your answer will be 2. It'll just fall out very cleanly. So right now, if we try and plug 0, 0 in here, we get 0 on top, 0 on the bottom. But if you come in with the conjugate and you do this after you do the conjugate, you won't get 0 over 0 anymore, you're going to get 2. So I'm going to let you do that. Just remember, this is kind of a trick. You can pull that out of the bag whenever you need to. All right, that's it.